Radiation, a single physical phenomenon. Atoms become unstable, nuclei decay, energy is released. But here's something strange. To describe this one process, we use three completely different units: Becquerel, Gray, and Sievert. Why? Why does physics, which seeks simplicity, need three separate measurements for the same reality? Let's sharpen the question. If radiation is just nuclear decay, why isn't one unit enough? Why do scientists insist on three? Are these just different ways of saying the same thing, or are they measuring fundamentally different aspects of the same phenomenon? Until we answer this, these units will always feel confusing. Here is the breakthrough idea. Radiation is not a single-layer phenomenon. It has three distinct layers of description. First, events. How many decays are happening? Second, energy transfer. How much energy is being delivered? Third, biological impact. What effect does this energy have on living systems? Same radiation, but three fundamentally different questions. And each unit answers only one of these. To make this deeply intuitive, let's step outside physics. Imagine gunfire. Now think carefully. How would you describe it? You could count how many bullets are fired. You could measure how much energy those bullets carry. Or, you could look at the injury caused. Three descriptions, same event. And importantly, these are not interchangeable. More bullets doesn't always mean more damage. More energy doesn't always mean more injury. This is exactly what happens in radiation. Now translate this analogy into physics. Bullets per second. This is like radioactive decay rate, right pointing arrow Becquerel. Energy delivered to the target. This becomes absorbed dose, right pointing arrow Gray. Actual injury or biological damage. This is measured by right pointing arrow Sievert. So now we see clearly. We are not measuring radiation differently. We are measuring different consequences of radiation. Let's start with the first layer, Becquerel. Becquerel measures activity. It simply counts how many nuclear decays are happening per second. 1 Becquerel means own decay per second. That's it. No energy, no damage, just count. So Becquerel answers a very specific question. How active is the source? But here's the critical limitation. More decays does not mean more harm. Imagine two sources. One emits many low-energy particles. Another emits fewer but highly energetic particles. The first may have higher Becquerel, but the second could be far more dangerous. Why? Because Becquerel tells us nothing about energy, and nothing about biological impact. It only tells us how often events happen, not how significant they are. Now we move to the second layer, Gray. Gray measures absorbed dose. That means, how much energy is deposited in a material or in the human body. 1 Gray equals 1 joule of energy per kilogram. Now this is much more meaningful than just counting. Because now we know how much energy actually interacts with matter. But even this is not the full story. Same energy does not always produce the same damage. Why? Because different types of radiation interact differently with biological tissue. For example, alpha particles cause dense, localized damage. Gamma rays spread energy more diffusely. So even if the Gray value is the same, the biological effect can be drastically different. So Gray answers how much energy is delivered, but not how harmful it is. This leads us to the third and most important layer, Sievert. Sievert measures biological effect. It takes the absorbed energy, and then adjusts it based on the type of radiation, and how sensitive the body is to it. In simple terms, Sievert converts physical dose into biological risk. So this is the unit that finally answers, how dangerous is this radiation? Now everything becomes clear. Becquerel tells us how frequently radiation events occur. Gray tells us how much energy is absorbed. Sievert tells us how harmful that energy is to life. 3 units, not because physics is complicated, but because reality itself has multiple layers. To truly understand radiation, you must see all 3 together. 1 phenomenon, 3 perspectives. And now, the confusion disappears. Next time you hear a radiation number, don't just ask, how much? Ask, Is it activity, energy, or actual risk?